I am Anil Kumar. Welcome to my series on exponential equations. How do we solve exponential equations is the major topic which we are going to cover in this particular video. Now these solutions will help you prepare for your own test. We have taken variety of questions which will cover solving exponential equations with common base. Sometimes you may have to rewrite the given equation so that you have the common base. In that case, you can compare the index, power, or exponents, as you may call, to get the answer. Many times it is not possible to write exponential functions with a common base, and then you use logarithms. So that is a prerequisite for this particular video. You should understand how to use logarithms. Now, one of the important formulas for logarithms which we are going to use is change of base formula. So let me write down the change of base formula here. We say log to the base a of x can be written as, we can change this base to, let's say, b. In that case, in the numerator, you'll get log to the base b of x, and the denominator will be log to the base b of a. So that is how you change the formula from base a to any other base. On a calculator, we have two functions which are normally available to you. So, especially in the test, whenever the calculator is allowed, we allow only two functions. One is called the log function, the other is ln. Now, for log function, the base is 10. The base is 10. And for ln, the base is e. Okay, so you could use one of these to solve your questions provided you understand the change of base formula. Correct? So let me just rewrite here what I'm trying to say. I'm trying to say that log to the base 10 of x, calculator function is log x. 10 is the default value. And log to the base e of x, you could write this as ln x. And that is to the base e. Correct? And this is the change of base formula where you can change base from a to b. B could be anything. Preferred b value will be 10 or e to solve the questions. Okay. Now, when we have exponential equations, we will have times when it could be treated as a linear equation or as a quadratic equation. In either case, we may or may not use logarithms to solve. Correct? So those are different varieties of questions. Now, change of base formula will be applied in questions where we have different base on either side of equality. In that case, we have to use change of base formula. Now, I will take an application question which will be based on the exponential decay. Next, we are going to cover how to solve equations based on e with natural log. All the concepts which we discuss in this video will be applied there. The only difference will be that in the next video, instead of using log x, we'll be using ln x. Let's begin with the common base strategy to solve equations, the exponential equations. So any equation which has exponent as variable is an exponential equation, right? So let me write down this note here. We'll say, what is an exponential equation? So equation with exponent as variable or independent variable, right? So many times we use different terms for exponent. We could use the term index or power. So any term can be used for exponent. So both these equations given to you are exponential equations. The index or the exponent or power is a variable x. Now when we say solve, we want to find the value of x, correct? That is the whole idea. So let us see how to solve this particular equation. Now we have 7 to the power of x as equal to 49. The idea is to write 49 with the same base, which is 7. So 7 squared, you know, is 49. Therefore, the solution is x equals to 2. So once you have the same base, the index or the power or the exponent should be same. So equate index when base is common. So this is the strategy which we are going to use, and that will take care of some very basic exponential equations to be solved. Now here we have slightly more complicated case. Let us see how to solve this one. It says 2 to the power of x minus 1 is square root of 8. Now we need to write square root of 8, which you could think about as 8 to the power of half in terms of 2 to the power of what? So we could say, well, this is 2 to the power of x minus 1 could be written as 8 is 2 cube, right? So you could write this as 2 cube and then a power of half. So that gives you 2 to the power of 3 by 2. Now we got the same base. We need to solve for x. How do we do that? So now how do we solve 2 to the power of 3 over 2 as equals to 2 to the power of x minus 1? We need to compute the exponent. So x minus 1 is now equal to 3 over 2, and that gives you that the value of x is 3 by 2 plus 1. And when you add that, what do you get? You can take 2 common as your denominator, and you get 3 plus 2 times 2 is 4. So the answer is 4 over 2, right? 4 plus 3 is 7, so you get 7 over 2 or 3.5 as your answer. So we are providing exact values. You could write 7 over 2 or 3.5 as your answer in this particular case. So the solution is x equals to 2 for the first example and x equals to 3.5 in the second example. You could always check your solution whenever you're working with exponential equations. In this video, we are not going to check it, but it is a good practice to check your solutions, right? So another important thing is check solutions. So I'm keeping this as a note. You should do it. Now, second example based on common base again is 4 to the power of 1 minus 3x equals to 64. So let's rewrite this. We have 4 to the power of 1 minus 3x equals to 64. Now, can you write 64 as exponent with 4 base? Yes, you could, right? 4 cube. So 4 cube is 64. Now, 1 minus 3x is equal to 3, and you can simplify this particular equation. Minus 3x equals to 3 minus 1, which is 2, and x is equal to minus 2 over 3. So you get your solution, which is x is equal to minus 2 over 3. You could actually check your solution. I'll leave that as an exercise for you, right? So I'll say check solution. At times, that could be part of your question. The next question here is 2 to the power of x minus 1 times 2 to the power of 2x equals to 1024. Well, 1024 is 2 to the power of 10 kilobytes, right? That reminds you. So 2 to the power of 10 is 1024. It is a very good number to remember. Let's write down the question itself, which is 2 to the power of x minus 1 times 2 to the power of 2x equals to 1024. Now, applying the laws of exponents, we could add the exponents. We have the same base. So we get 2 to the power of x minus 1 plus 2x is equal to 2 to the power of 10. Since we have the same base, we could compare the exponents. So we have x minus 1 plus 2x is equal to 10. This is 3x equals to 10 plus 1, which is 11, and we get the value of x as 11 over 3. So our answer in this case is x is 11 over 3. Clear? Next question here is, we will take logarithms to solve the questions in this particular category. Now you will see that we have the question here written as 4 to the power of x equal to 6. I really cannot write 6 as power of 4. We know 4 to the power of 1 was 4 and 4 square is 16. So 6, well, we don't know. So therefore, in such cases, we have to take logarithms on both the sides. So we could write this as log of 4 to the power of x equals to log of 6. Now this is log to the base 10. So normally that 10 is not written, but I'm just writing it here as my first example in this particular video, just to remind you that we are working with the base 10. And now we'll use the power rule, which is x times log to the base 10 of 4 is equals to log to the base 10 of 6. And the value of x will be the ratio of log to the base 10 of 6 over log to the base 10 of 4. So this particular is your answer. If it is exact value, in that case, you will leave it right here. How we want to write the answer to 4 significant figures. So let's calculate using the calculator. On the calculator, you have this log function, which is to the base 10. So I'm calculating log of 6 and then dividing this by log of 4. And what I get here is equal to 1.29248. 1.29248. We need to round our answer to 4 significant figures, right? This is kind of important. 4 significant figures. That means what? So that means the answer should be written as 1 point. So up to this point, correct? So 3 more decimal places, 292 in this case. So that becomes your answer to 4 significant figures. Is that clear to you? So that is how you're going to write down your answer rounded to the given accuracy. Perfect. Now, I'd like you to pause the video and answer the next question. Follow the same strategy. So let's copy the question first, which is 7 to the power of x minus 2 equals to 1000. Now we'll take log on both the sides. So when you take log, it becomes log 7 to the power of 7x minus 2 equals to log of 1000. I'm not writing 10, it is always default value, and so you need not write it. Now in this case, we'll apply the power rule. You get x minus 2 of log 7 is equal to log of 10 cube, and the value for this is 3, right? So you could, one more step will go 10 cube, and that value is 3. And so we can now write down the answer, which is, let's go one more step, x minus 2 is equal to 3 over log 7, and rearrange. X is equals to 3 over log 7 plus 2. So that becomes your answer. Let's use the calculator and calculate this. So we'll divide 3 by log of 7. And then we'll add 2 to it. What we are getting here is 5.54988. We have to round this to 4 significant figures. That means 3 decimals, right? So we get 5.550. So that becomes your answer to 4 significant figures. Perfect. So this is to 4 significant figures. Let's take the next example, which is solve 3 to the power of 5x times 9 to the power of x squared equals to 27 without calculator. Provide exact answer. So let's do it. We have 3 to the power of 5x times 9 to the power of x squared equals to 27. Now 9 can be written as 3 square, right? So we can write this as 3 to the power of 5x times 3, which is squared, 9 is 3 square, over x squared equals to 27. 27 you could write as 3 to the power of 3, right? Okay. So Using the laws of exponents, it gets multiplied, right? So let's write this as 3 to the power of 5x times 3 to the power of 2x squared is 3 to the power of 3. Now they get added up, so we can write this as 5x plus 2x squared equals to 3. Comparing the exponents, since we have the same base, so we can compare the exponents and write down our equation. Now this equation happens to be a quadratic equation. Let us see how to solve this equation. Let me rearrange, get all the terms on one side. So we get 2x squared plus 5x minus 3 equals to 0. We could factor using sum and product. So we could write the center term as we want 6, right? 2 times minus 3 is 6. So 6 and 1 can work for us. So we could write this as 2x squared plus 6x minus x minus 3 equals to 0. So we can take 2x common. So we get x plus 3 minus common x plus 3 equals to 0. X plus 3 is common. So we get 2x minus 1 equals to 0. And this gives us two values. X is minus 3 and x is equal to half. So these are the two values for which the equation is true. Now, what you need to figure out whether this is minus 3, right? Whether these values really work or not. Well, as far as the equation is concerned, we know x belongs to real numbers, so negative value could work, correct? However, I would like you to check. So check solution. Check solution really means that you have to substitute the value and then figure out whether they are right or wrong. For the time being, I will write this as correct answer. Is that okay? If you find that doesn't really work out, you have to let me know. So x equals to minus 3 and x equals to 2, half is the solution of this particular equation. Question number 4a. Solve 2 to the power of 2x minus 10 times 2 to the power of x plus 16. Now in such equations, we could actually write this in quadratic form. So we'll use a let statement saying let 2 to the power of x be equal to some number t, right? So t is our variable now. So we get the question given to us is 2 to the power of 2x minus 10 times 2 to the power of x plus 16 equals to 0. We are substituting t for 2 to the power of x. So we get t squared minus 10t plus 16. Now this quadratic equation can be factored, product and sum. So we get 16 as 8 and 2. So we could write this as t minus 8 times t minus 2 is equal to 0. So that gives us two solutions. One is t equals to 8, the other one is t equals to 2. So t was 2 to the power of x, so we can write 2 to the power of x is 8 and 2 to the power of x is 2, and that gives you the answer as x equals to 3 and x equals to 1. Perfect. So we get our solution, which is x equals to 3 and x equals to 1. So I hope it is clear why it is so. Because 8 is 2 cubed and 2 is 2 to the power of 1. Perfect. So that is how you're going to do it. Let's take another example on the same basis. However, now here is another question which we can write in quadratic form and then solve. The question here is 3 to the power of 2x plus 1 minus 26. 3 to the power of x minus 9 equal to 0. We can substitute 3 to the power of x as, let's say, t. Now, before substituting, we should actually simplify our equation. When we say 3 to the power of 2x plus 1, what does it mean? It really means we could write this as 3 to the power of 2x times, that plus 1 is times 3, right? And here we have 26, 3 to the power of x minus 9 equals to 0. So this 3 is the coefficient of 3 to the power of 2x. I could write this now equation as 3t squared minus 26t minus 9 equals to 0. Is that clear to you? Perfect. Now we are looking for sum and product. We want the product of 3 times 9, which is 27, and sum of minus 26. Product is also negative. So we could write minus 26 as minus 27 plus 1. So we get minus 27t plus t. Now we can group factor. Taking 3t common, we get t minus 9. Here we already have t minus 9. Taking t minus 9 as a common factor, we get 3t plus 1 equals to 0. And that means t could be either 9 or t could be minus 1 over 3. So we have two values of t. Now remember that if 3 to the power of x is t, then what do you expect? We expect t to be greater than or equal to 0, right? So therefore, we'll take the valid answer, which is t to the power of 9, but we cannot take the other answer, which is not valid. So now we'll continue with t equals to 9. That means 3 to the power of x equals to 9. And now the common base 3 square. So we get x equals to 2 as the solution. Now once again, it's a good practice to check. However, we'll treat this as the right solution. So let's move on and take the next question, which is also a form which can be reduced to quadratic form. Now the question is 1 plus 2 to the power of x minus 6 times 2 to the power of minus x equals to 0. Well, that really means I could write this as 1 plus 2 to the power of x minus 6 times 2 to the power of minus x means it comes in the denominator. We can multiply by 2 to the power of x and simplify the equation. So we'll now substitute 2 to the power of x as t. Then we get 1 plus t minus 6 over t equals to 0. Multiplying by t, we get t plus t squared minus 6 equals to 0. Or you can rewrite this as t squared plus t minus 6 equals to 0. So we again get a quadratic form. This can be factored and then we can find the solution. So we could factor this 3 times 2. So I could write this as t plus 3, bigger number is positive, t minus 3 equals to 0. That gives us two solutions, t equals to minus 3 and t equals to 3 times 2, right? So I should have written 2 here. Okay. So t equals to 2. So that becomes the solution. The valid solution is we're looking for a positive value of t, right? So we know t is greater than 0 or it could be equal to 0. So t equals to 2 is the right solution. We get 2 to the power of x is equals to 2, which implies that x is equal to 1. And so our answer here is x equals to 1. Clear? So that is how you solve these equations. I hope you're finding it simple. Now, we have a very interesting question. This time, we have to use logarithms on both the sides to solve the equation 7 to the power of x plus 1 equals to 3 to the power of x plus 2. Now the question here is, use logarithms on both sides to solve 7 to the power of x plus 1 equals to 3 to the power of x plus 2. Since we have exponents on both the sides, we need to take log on both the sides, correct? Even otherwise, you take log on both the sides. We have 7 to the power of x plus 1 equals to 3 to the power of x plus 2. Taking log, we get log of 7 to the power of x plus 1 equals to log of 3 to the power of x plus 2. Now using the properties of log, we get x plus 1 log 7 equals to x plus 2, let me write here, x plus 2 log 3, correct? We can expand and simplify. So we get x log of 7 plus log 7 equals to x log 3 plus 2 log 3. Let's bring x terms together. We get x log 7 minus x log 3 equals to 2 log 3 minus log 7. We can now isolate x by first factoring. So I'll rewrite my equation with x as a common factor. So we get log of 7 minus log of 3 equals to 2 log of 3 minus log of 7. So from here, we can write the value of x as equal to 2 log 3 minus log 7 divided by log of 7 minus log 3. Is that clear to you? So that becomes the answer. Now we need to calculate the particular answer. We can use the calculator. 2 times log of 3 minus log of 7, and we are going to divide this by log of 7 minus log of 3. We get this as equals to 0.2966. Now let's write down this answer to three significant figures. So we get 0.297 as our answer. Correct? So that is how you could actually solve the particular question. So I hope that makes sense, right? So I'd like you to once again check your solution. So when you check, you substitute the value of x and then c. So let me check this. We get 7 to the power of, I'm adding 1 to it, so you get 1.297. Because we have rounded this figure, we may not get exactly the same answer, right? So we'll see what do we get. So 1.297. What we get here is the left side is 12.4764. This is the left side. And if I do the right side, which is 3 to the power of 2 plus, so it is 2.297, which is 12.4723. So slight error is there, but this is because of rounding, because we rounded this up. But they are close, right? So it is the correct answer. So that is how you're going to check it. Now let's take the last example, which is an application question. A radioactive substance has a half-life of 200 years. Determine the age of substance if it has retained 70% of its original amount. So that's a very interesting question. I'd like you to pause the video, write down the equation and try to solve. So let's review the concepts learned about writing equation of a half-life, right? So you could write an equation saying that the amount left A will be equal to what? They're saying 70%. So it is out of the original amount. And whenever you're given half-life, the formula will be half time period over. We are given the age of the substance, half-life of 200 years. Let me write y as my variable for number of years. Now, when we say that it has retained 70%, so the amount today is 70 out of 100. So we could write this as 70 and out of 100. You could use this, or you could also write 0.7. But anyway, we'll kind of do it like this and t over the half-life of 200 years. So 200. So we have half-life of 200 years. So we'll substitute y equals to 200 in this particular case. That is in years. That is why I used y. Kind of tricky variable to use, difficult to use actually. Anyway, now the only variable left is t. So time in years. T is time in years. So we can solve this equation and find the answer. So 70 divided by 100, which is 70%, of half of t to the power of half to the power of t over 200. So it is 0.7. We can take log both sides. We get log of 0.7 equals to t over 200. Applying the properties of logarithms, log of half, right? So I've done two steps at this stage. By now, I think you understand all this. So we can now write down t as cross multiply 200 times log of 0.7 divided by log of half. Is that clear to you? So that becomes the time. And this time is in number of years. So let's find this answer using the calculator. So we'll do log of 0.7, divide this by log of 0.5, sorry, it was, 0.7, divide by log of 0.5, and we'll multiply this by 200. What we get here is 102.9. So many years, you can say approximately 103 years. So that becomes the solution of the given question. Perfect. So that is how you're going to solve equations. So once again, you can see how in an exponential equation, we find the value of the exponent taking log on both the sides, right? So we found the time. So let's see what we did just now. We began with understanding the concepts. You can actually solve exponential equations using the concept of common base. And if that is not possible, you have to use logarithms. So these are the two choices for you. Make common base and then, or you use logarithms. While in between, as you solve all the types of equations, you could have linear equations type, you could have quadratic equation types, and those could be solved in standard ways. And then at the end, you could use log to the base 10 to get the answer. Perfect. In the next video, we'll see how to work with base of e and ln x. I hope that makes sense. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.